we're going to look at what is called the remainder theorem. Now, the remainder theorem is discussed on from page 272 of the book Pre-Calculus 7th edition, which I downloaded free online. It's a PDF file. Here, what it says is the remainder theorem. If the polynomial px is divided by x minus c, then the remainder is the value p of c. Alright, let's look back at this. So, what that means, if this polynomial is divided by x minus 1, then the remainder must be f of 1. Notice, it's divided by x minus c, then the remainder is p of c. Let's try it with this. In previous videos, we divided this polynomial by x minus 1, and we got a remainder of 3. That means if this is p of x, looking back, p of x is divided by x minus c. Our p of x here is divided by x minus 1. Then the remainder is p of c. So the remainder, in our case, must be equal to p of 1. Let's try. You get p of 1. If, remember, this is p of x. Let me rewrite the x here. This is p of x. Is that. And it is divided by x minus 1. Then p of 1 must be the remainder. Now, if we try that, what we're going to get is 3 times 1 to the 5th minus 2 times 1 to the power of 4 plus 1 squared minus 5 times 1 plus 6. Let's see how it works out if it's really 3. 3 times 1 to the 5th is just 3 by 1, which is 3 minus 2 by 1 to the 4th is just 2. Plus 1 squared is 1 minus 5, 1, 5 plus 6. 3 minus 2 is 1. 1 plus 1 is 2. So it's 2 minus 5 plus 6. This is 2 minus 5 is negative 3. So negative 3 plus 6 is 3. Oh, well, it does work out with this example. The remainder is 3. They present this example here. It says p of x is 3x to the 5 minus 5x to the 4 minus 4x cubed plus 7x plus 3. Find the quotient and remainder when p of x is divided by x plus 2. Use the remainder theorem to find p of negative 2. Alright, what they do is use synthetic division to find the quotient and the remainder when it's divided by x plus 2. Now, I want you to do that on your own. Pause the video and do a synthetic division, and let's see what you get. Let me zoom it up a bit. So go ahead. Alright, good. You've paused the video and you divided 3x to the 5 plus 5x to the 4 minus 4x cubed plus 7x minus plus 3 by x plus 2. Alright, what did you get? So you would have got 3x to the 4 minus x cubed minus 2x squared plus 4x minus 1, remainder 5. If that was not what you got, I want you to pause the video and do it again, check back, and it's still not what you got, pause the video and try again. Alright? Now, suppose you are just asked to find the remainder when the polynomial is divided by x plus 2. What would happen? Let's see. Imagine you're in an exam and you were not asked to divide it. You're asked to find out, or you are asked to find the remainder when this polynomial is divided by x plus 2. You must show working. What will you do? Alright? What the remainder theorem says is that when you divide by x minus c, the remainder is p of c. Now x plus 2 is the same as x minus negative 2. So the remainder is supposed to be p of negative 2. If you consider this polynomial as p of x. Alright? Here now, to find p of negative 2, you're going to substitute negative 2 for x. So you have 3 times negative 2 to the power 5 plus 5 by negative 2 to the 4th. See that? So you put negative 2 where x is. This is 3x to the 5th. So you put 3 negative 2 to the 5th plus, this is 5x to the 4th. So you're going to have 5 times negative 2 to the 4th minus 4x cubed will become 4 by negative 2 cubed plus 7x. This becomes 7 by negative 2 plus 3. Now, remember, you're supposed to get the remainder as the same remainder when you did the division. So we're going to work out what the remainder is. 2 to the 5 is 32, but a negative 2 to the 5 is going to be negative 32. So 3 times negative 32. What do you get? You're going to have 3 times 32 is 96, but a negative 96. So you have negative 96. Now negative 2 to the 4 is 16. Positive 16. And you're going to find 5 times 16. So what you get is 80. So this is plus 80 minus, now negative 2 cube will be negative 8. So it's a 8 fourths 32. It's minus negative 32, which is the same as plus 32. Then 7 by negative 2 will be a negative 14 plus 3. So what do you get here? You're going to have and negative 96 plus 80 plus 32 minus 14 plus 3. What do you get for it? Alright, I got 5. Let's check what we did earlier. What was the remainder? The remainder was 5. And you got 5 here. Alright. It means that if you're in an exam and you're given this polynomial and you're asked what is the remainder when you divide by x plus 2, you don't necessarily have to go through that division. You just substitute negative 2 for x. If you're asked to use the remainder theorem to find the remainder when it is divided by x plus 2, that means you're not supposed to divide. Don't do it using the division. What you do is substitute negative 2 for x. Alright? Now, remember, if you had a case where you had this polynomial and they say, what is the remainder when it is divided by x plus 1? What you substitute is you're going to make x equal negative 1. If you're asked what is the remainder, or use the remainder theorem to find what the remainder is when it is divided by x minus 2, then you make x positive 2. What is the remainder when the polynomial is divided by x plus 2? Then you make x negative 2. It's like you're saying x plus 2 equals 0. What is x? X equals negative 2. Alright? If you're given a polynomial and you're asked to use the remainder theorem to find out what the remainder is when the polynomial is divided by x plus 3, you say when x plus 3 equals 0, x. When x plus 3 is 0, then x is negative 3. So you make x equal negative 3 and you put negative 3 there for x. If you're asked you're asked to use the remainder theorem to find out what the remainder is when the polynomial is divided by x minus 3, then you make x equal positive 3 and you replace x with positive 3. It's like saying x minus 3 is 0. What is x? X is going to be positive 3. Alright? So, to recap, if you have a polynomial and the polynomial is divided by another polynomial, by a linear equation, and you're asked what is the remainder when it's divided by that linear equation, equate the linear equation to 0, find out what x is and put x. Put the value for x. And what you get when you do the calculation is the remainder. Alright, so that's it for this video. We'll continue looking at the remainder theorem in other videos.